So this is how the orbitals are revolving and the combination of electrons is happening. You are able to see it. So there is a clash. So clash includes the combination of electrons happening. The change of electron affinity along a group. So on moving down a group, the size of the atom increases significantly and hence the effective nuclear attraction for the electron decreases. Consequently, the atom will possess less tendency to attract additional electrons towards itself. It means that electron affinity would decrease as we move down a group. In case of halogens, the decrease in electron affinity from chlorine to iodine is due to the steady increase in atomic radii from chlorine to iodine. On moving down a group, the electron affinity decreases. Thus, the electron affinity of chlorine should be lesser than fluorine. But actually, the electron affinity of fluorine 320 kilojoule is less than chlorine, it's 348 kilojoule. The reason for this is probably due to the small size of fluorine atom. The addition of an extra electron produces high electron density, which increases the strong electron-electron repulsion. The repulsive forces between electrons result in low electron affinity. You are able to see the electron affinities for the noble gases are 0, as these atoms possess NS2, NP6 configuration in their valence shells. These are the stablest atoms and there are no chances for the addition of an extra electron. Thus, the electron affinities of noble gases are 0. The electron affinity of beryllium and nitrogen are almost 0. This may be due to the extra stability of the completed 2s orbital in beryllium and the exactly half-filled p orbital in nitrogen atom. You are able to see the nitrogen atom. So, as these are stable electronic configurations, they do not have tendency to accept electrons, and therefore the electron affinities for beryllium and nitrogen is 0. So it doesn't need any electron. On moving across a period, the size of the atom decreases and the nuclear charge increases. So the size of the atom decreases and increase in nuclear charges. Both these factors favors an increase in the force of attraction exerted by the nucleus of the electrons. Consequently, the atom will possess a greater tendency to attract the additional electrons. Therefore, its electron affinity would decrease as we move from left to right. Due to this reason, electron affinity of non-metals are high, whereas those of the metals are low, because it increases from left to right. Of all the metals, the electron affinity of gold is comparatively high. It's 227.7 kilojoule per molecule. This value may be attributed to the higher effective nuclear charge and poor shielding of the nucleus by the d electrons. This is the structure of gold.